This is going to be a review over the systems of equations with linear combination and applications. Right here, number 1 says, Kyla is solving the following system by linear combination with tiles and algebra. Show the first step with tiles and the algebra for the following system. So with the tiles, when I go through to draw this, you need to remember that a rectangle is an X, a longer rectangle right there is a Y, and then our units, our small ones right here, are just ones. So I'm going to have the first equation says X plus 2Y right here. All right, now I'm going to draw my line for equals. Equals 8. 1, 2, 3, 4, 5, 6, 7, 8. The next one right here says X minus 2Y equals negative 2. Let me color those in. Now what I'm going to do, I'm going to eliminate. See right here we have 2y minus 2y. Those are those 0 pairs right here, and this cancels out. So how many x's do we have? We have 2x. Well, here they are right here. This x, oh, they're all going to go together here. If I went to go rewrite it, I have the 2 x's, and it equals, and 1 takes away a negative 1, a positive 1 takes away a negative 1. So right here, I get equals 6. So 1, 2, 3, 4, 5, 6. That's all they wanted us to do, was to show the first step. The next one, it says Cade wants to solve the following system of equations by using linear combination. What should he multiply the first equation by if he wants to eliminate the y terms? Okay, so right here, if I want to get rid of the y's, look at this. What times 3 gives you 15? Because you need these numbers to be the same. If I wanted to do it by the y's, you would multiply a 5. The problem is they're both positive, so this would be a negative. So you would multiply by a negative 5. No. Now see, I wrote negative 5y, and that's what I saw a lot of times on people's tests. You don't put the y, just that number, negative 5. Okay, so now the next question says, what should he multiply the first equation by if he wants to eliminate the x term? So looking at these x's, what number needs to be up here? This is a 7. I need that number up there to be a 7. Problem is, both of them again are positive. I need this one to be negative. So I'd multiply by a negative 7. Next problem, it says Jacob wants to solve the following systems of equations by using linear combination. What should he multiply the first equation by to get rid of the y term? If you look at the y's right here, well, I need this to be the exact same number that's down here. I need it to be an 8. Now the next thing you look at is both of them are positive, so you need this to be a negative 8. So I would multiply by negative 8 to get rid of the y's. To get rid of the x's, that's what the second one says. What do you need to multiply the top equation by? Well, 8 times what gives you 16? That is a negative 2, because I need this to be negative 16. You should have multiplied this by negative 2. Next, which method would be most efficient in solving each system? Choose either graphing, substitution, or linear combination and explain why. When you use graphing, it's easier when they're already in y equals form and already set up to where you can put them in the calculator. Substitution, when one is in standard form and another one says x equals or y equals, that's when you use substitution. Linear combination is when both of them are in standard form. That's when it's the easiest to use that. So right here, when you look at this, I have one of them that's in standard form, the other one is in y equals. So in this case, it is easier to use substitution. In this one, when you're looking at it, see how this is in standard form, both of them? See, when I go to eliminate, the x's cancel out. This is easier by using linear combination. Number 5, or I guess number 6, it says Mary has 5 more than twice as many books as Carlos. Together they have a total of 70 books. Write a system of linear equations that can be used to find out how many books Carlos has and how many books Mary has. Well, first off, it says Mary has 5. Remember, more than means addition. 5 more than. Twice as many books. Twice means 2 times as many as Carlos. So I have 2C. The next equation says together they have a total of 70 books. That means that Mary plus Carlos equals 70. From here, they want you to solve it. Now, you right here, you could use substitution and go through and do it, but let's talk about problem solving when we're talking about trying to find these answers. First off, I know when you add them together, they should equal 70. So if I look here, if I add these together, that gives me 77. That doesn't work. What about this one? What about 47 and 21? That gives me 68. Well, even this one here, that gives me 68. That doesn't work either. So actually, none of these are reasonable because it doesn't work because they don't equal 70. So let's see what happened. Let's see if the problem got written wrong or if I'm missing something. Okay, so I'm going to take this right here and I'm going to substitute it in here. I get 5 plus 2C plus C equals 70. So let's see here. I've got 5 plus 3C equals 70. Subtract 5 from each side. 3C, whoops, that's a 6 there. I didn't mean to write that. 3C equals 65. You divide by 3. It doesn't work out very evenly. C equals, this is 20. Let's see here. That goes in there once. 2 left over, an 8. Let's see, and we go through and it doesn't work out very nicely. Okay, so if you look at this, trying to figure it out, they said that they equaled 70, but none of them work. What is the most reasonable solution? Okay, well, if you look down here, it says C equals 21. Okay, so we're going to go with a reasonable. What's closest to it is that Carlos has 21 books. And if Carlos has 21, let's take Mary equals 5 plus 2 times C. Mary equals 5 plus 2 times 21. So we have Mary equals 5 plus 42. So Mary equals 47. Okay. So when you look up here, now the question is which one of these 2 answer choices would it be? I mean, I guess because it says most reasonable solution, it's not going to be the exact. When you have different letters, X and Y goes in alphabetical order. So these letters need to be in alphabetical order. Carlos and Mary. So this would be 21 and this would be 47. So the answer that's most reasonable would be A. The next one. It says an appliance store delivers large appliances using vans and trucks. When loaded, each van holds 6 appliances and each truck holds 10 appliances. If 7 vehicles are used to deliver 54 appliances, write a system of equations that could be used to figure out the vans and the trucks. Solve and show all work. So let's write our system. First off, the vans plus the trucks. How many vehicles do they have? They have a total of 7 vehicles. So the vans plus the trucks equals 7. Okay. The vans hold 6. So we're going to have 6 appliances times the vans plus 10 appliances times the trucks. And it equals 54. There is my system. Now we need to solve it. So the easiest way is to use it is by linear combination. Let's look and see what can I multiply this top equation by if I wanted to get rid of the t's right here. You want to multiply by -10. So I'm going to multiply each one of these things, and I'm going to write it out here to the side. I'm going to get -10v minus 10t equals -70. Rewrite the bottom one, just leave it there like that. Now you could have multiplied the top equation by -6 if you wanted to get rid of the v's first, but it doesn't matter which. So right here, when you put those together, you get -4v. The t's cancel out. And right here, you get -70 plus 54 is -16. Divide by -4. V equals 4. So I have 4 vans. Now I need to figure out how many trucks. Well, think about this. If vans plus the trucks equals 7, 4 vans plus how many trucks equals 7? The trucks are 3. Number 8. Now in this one, notice it says do not solve. It says a math test has 25 problems. Some are worth 2 points, some are worth 3 points. The test is worth 80 points total. Write a system of equations to determine the number of 2-point problems and the number of 3-point problems. Now you can use any letters you want. I'm going to go ahead, because I need to define my variables, I'm going to use x equals and y equals. X is going to be my 2-point problems. Y is going to be my 3-point problems. Now, the first equation is going to say that we have 25 total problems. So I have x plus y, and that equals 25. Now, find out what the value is, because it says the test is worth 80 points. So I'm going to take 2 points times the number of 2-point problems, plus 3 points times the number of 3-point problems, and that equals 80. Here's the next one. Again, this one says do not solve. Michelle scored 4 fewer than triple the number of points of Kathy in a basketball game. Together, the girls scored 26 points. So it says let M equal the number of points Michelle scored, and C equal the number of points Kathy scored. So we're going to write a system. Well, the first sentence up here, we're going to write one that matches that first sentence. It says Michelle scored. Now it says 4 fewer than. This right here is your key. We need to hold off on that 4 because fewer than, we're going to do some kind of subtracting. Triple means 3 times the amount of points that Kathy has. So it should be 3 times the amount Kathy has. And then 4 fewer than, you subtract 4. So let me bring this equation down. And, oops, let me erase these little stray marks. The next one says that they scored a total of 26 points. So Mary's points plus Kathy's points equals 26. That's your system. All right, here's the next one. It says the entry fee to a basketball game is $4 for adults and $2 for students. Tuesday, the school collected a total of $428 from 178 people. Write a system that can be used to find the number of adult and student tickets sold in the game on Tuesday. Okay, to write your system, first we need to define our variables. We're going to have A equal the adult tickets, and S equal the student tickets. Now, I like to put the dollar amounts with it. The adult tickets are $4. The student tickets are $2. I guess I missed another T in there because I crammed it all together, didn't I? That's all right. To write my first system, let's talk about how many people showed up to the game. Adults plus the students. There was 178 people that showed up. The next one, let's talk about how much money was raised. You have $4 times the adult tickets plus $2 times the student tickets, and that equals 428. Now, down here, it wants us to solve it. Well, what if let's get rid of the S's. What do we need to multiply the top equation by to get rid of the s's? I need to multiply the top equation by -2. So I'm going to do the distributive property. Make sure you multiply by everything. Right here, -2 times a is -2a. -2 times s is -2s. -2 times 178. Let's see here. Having technical difficulties here. -2 times 178 is -356. -356. Okay, so now I'm going to put together these two equations right here. Okay, normally I write it out to the side, but I ran out of room here. These s's cancel out, and I get 4 minus 2, which is 2a, equals, and if you take this right here, 428 minus 356, you get 72 divided by 2. The adults equal 36. Now it says the other equation is the adults plus the students equals 178. So I have 36 plus the students equals 178. So when we subtract 36 from each side, my students equals, I have 142. So now it says in a complete sentence, explain the meaning of your solution. Well, it means that 36 adults and 142 students attended the basketball game. The next one, right here, remember it says do not solve. It says the Burrito Shack sells burritos for $4 and tacos for $2 each. One day the shop sold 20 more burritos than tacos and made $225. Write a system that can be used to find the number of B burritos, and I guess they're using C for tacos. Well, first off, let's figure out how much money they made. You take $4 for the burritos times B plus $2 times the tacos, and they're using C for tacos, and they made $225. There's your first equation. The next equation coming up here, one day the shop sold 20 more burritos than tacos. Well, first off, what did they sell more of? They sold more burritos. So I have my burritos equals 20 and more than is plus the number of tacos. There's your system. And if we talked about this, what would be the easiest way, the way it's set up right now? Would it be better to solve it by graphing, linear combination, or substitution? In this case, because we have B equals right here, it'd be easier to use to solve by substitution. Okay, here's the next one. Let's solve by linear combination right here. They're both set in standard form. I'm going to draw my line. I'm going to get 5x. My y's cancel out, equals 10. Divide by 5. X equals 2. So I know for my solution I have 2 and I need to find the y. You can choose either one of the two equations. I'm going to choose 3x plus 4y equals 18. Now x is 2. I'm going to put this in right here. I have 3 times 2 plus 4y equals 18. 6 plus 4y equals 18. I'm going to subtract 6 from each side. 4y equals 12. Divide by 4. Y equals 3. There's your solution. Next one. Right here when I go to solve, 4x and 3x is 7x. The y's make 0 and go away. 11 plus 10 is 21. Divide by 7. X equals 3. So I have 3, and I need to find my y number. Choose one of the two equations. I'm going to write this one out here to the side. 3x plus y equals 10. I know that x is 3, so I'm going to substitute this in here. Be very careful. This says 3 times x. So you need to take 3 times 3. The x comes out. We are replacing it. Do not put another x here. Plus y equals 10. 3 times 3 is 9, plus y equals 10. Subtract 9 from each side. Y equals 1. My solution is 3, 1. The next one, let's go. And if I go to solve this by linear combination, 6x plus 3y equals 24. Wait a minute, there's a problem. One of my letters does not disappear. Okay, so that means I need to look, and I've got to see, is there a way that I can multiply one of my equations to get rid of a letter? I can do it either for the x or the y. I'm going to choose to do it for the y, but if you did the x, you still should come up with the same solution. What number needs to be up here to be the same down with this one? I needed this to be a 2. So when I multiply the y right here by 2, the problem is both of them are positive. I need one of them to be negative. So you're going to do the distributive property. Please make sure you do it by all of it, even that 14. That'll be one of your mistakes if you missed it. Negative 10x, because negative 2 times 5. Negative 2 times y is negative 2y. Negative 2 times 14 is negative 28. We'll rewrite the bottom one. X plus 2y equals 10. Draw your line. This gives you negative 9x. These cancel. Equals negative 18. Divide by negative 9. X equals 2. So my solution, I have 2. Then I need to find my y number. Choose either one of these equations. I'm going to choose this bottom one. Bring it down here. X plus 2y equals 10. I'm going to take this 2 and I'm going to substitute it in here for x. So x is going to come out, and I'm going to put 2 plus 2y equals 10. Subtract 2 from each side. 2y equals 8. Divide by 2. Y equals 4. The next one, number 15. Let's see what happens. Well, if I combine these, oh, this is good because this is 2x, and my y's cancel out. They make 0. 4 minus 2 is 2. Divide each side by 2. X equals 1. So my solution, I have 1 and then some number. I'm going to take my top equation. Why did I choose my top one? I did it because it was all positives. But you can choose either one. And it says x is 1. So I'm going to substitute. I'm going to put 1 right in there. 1 plus y equals 4. I'm going to subtract 1 from each side. Y equals 3. Number 16, right here. Is there a letter that automatically disappears and goes away when you combine them? Sure is. The x's will go away. X minus x is 0. I get 5y equals 2 minus 2 is 0. A lot of people get confused right here. Go ahead and finish and divide by 5. Y is 0. 0 is a good number. So now when I go up here, choose one of the two equations. I'll choose this top one because it's all positive. So I'm going to bring it over here. I've got x plus 2y equals 2. Y is 0. I'm going to come up here and put it in here for y. So I get x plus 2 times 0 equals 2. 2 times 0 is 0. X equals 2. My solution is 2, 0. Number 17. Okay, if you combine these, is there a letter right now that it automatically, when you put them together, goes away? No, there is not. What could I do if I wanted to get rid of the x's first? What could I multiply this bottom equation by? You're right, it would be negative 3. It'd have to be a 3 because I need this to be a 3, but since this is positive, the bottom one needs to be negative. You can do this, or a lot of times I look and see, is there already one of the letters that's positive and negative? Well, the y's already are. This is a 2y. I need this to be a 2. So I need to multiply the top equation by 2. I'll go ahead and do it this way. But if you multiply at the bottom by negative 3, that's fine. You'll still get the same answer. I'm going to multiply all three of these. Make sure you multiply that last one. That's one of your big mistakes. 2 times 3x is 6x. 2 times negative y is negative 2y. 2 times 8 is 16. Rewrite the bottom one. 6x plus 1x is 7x. The y's cancel out. 16 plus 5 is 21. Divide each side by 7. X equals 3. So I have 3, and then I need to find the y number. Choose one of the two equations. I'll choose the bottom one. I only chose that one because it was all positive, and I like that better. But either way, you'll get the same answer. The x is 3. I'm going to take that 3, and I'm going to put it in there for x. So x is coming out. 3 goes in. Plus 2y equals 5. Subtract 3 from each side. Oh, let's move this down just a little bit. 2y equals 2 because 5 minus 3 is 2. Divide each side by 2. Y equals 1. So my solution is 3, 1. Number 18. Is there a number right now? Or is there, I'm not a number, but is there a letter right now that disappears and cancels out? Nope, because that right here makes 12. That makes a negative 7. If I look at the y's, is there any whole number that you can multiply by 2 to get to 5? No. What about the x's? What can I multiply 3 by to get to 9? I could multiply it by 3. But I need this to be a negative 3 because this is positive. I need this to be negative. So I'm going to rewrite out to the side my top equation. I didn't do anything to it. Now the bottom equation, I need to take negative 3 times 3x, negative 9x. Negative 3 times negative 2y is plus 6y. Negative 3 times negative 2 is positive 6. Now let's combine them. The x's cancel. Negative 5 plus 6, that's a positive 1y. Negative 2 plus 6 is a 4. My solution, remember it goes x then y. Make sure you put it in the right spot. Now I need to choose one of these two equations. Ugh, they both have negatives on them. I'm just going to choose the top one just for fun. But it doesn't matter which one you choose to find your answer. I have 9x minus 5y equals negative 2. Your y is 4. That's going to come up here and you're going to put it in there. I've got 9x minus 5 times y is 4 equals negative 2. 9x, negative 5 times 4 is negative 20 equals negative 2. Add 20 to each side. 9x equals 18. Divide by 9. X equals 2. My solution is 2, 4. Number 19. Is there a letter that automatically cancels out and goes away when you combine them? This gives you a 5x. This gives you a negative 1y. It does not. Does 2 go into 3 evenly? Is there anything times 2, a whole number that will give you 3? No. What about a y's? If I got that, I've got a 1 positive, 1 negative. What number has to be up here with the y? Yes, it needs to be a 2. So let's multiply the top equation by 2. So if I go up here and rewrite this, I have 2 times x, which is 4x, 2 times y, plus 2y, 2 times 5, which equals 10. Rewrite the bottom equation, 3x minus 2y equals 4. Now, I get 7x, because 4 plus 3 is 7. The y is 2 minus 2 is 0, equals 10 plus 4 is 14. Divide by 7. X equals 2. So now, choose one of the two equations. I'm going to choose this one here, just because it doesn't have any negatives, but you could use the other one again. Okay, so I've got this. So now X is 2. So I'm going to take this 2 and I'm going to put it in here. I have 2 times 2 plus y equals 5. 4 plus y equals 5. Subtract 4 from each side. Y equals 1. Now, right here, let's look at this one. Is there a letter that automatically disappears? No, there's not. And does 5 go into 7 evenly? No. Does 3 go into 9 evenly? Yes. If I took 3 times 3, it would give me 9. But both of them would still be negative. I don't want that, so I need to multiply by a negative 3. So now let's rewrite the top equation. Okay, so I'm going to draw this out to the side. And I'm going to get negative 3 times negative 3, which is 9x. Negative 3 times 7, which is negative 21y. And negative 3 times 16, which is going to give you a positive 48. Let's rewrite the bottom equation. Negative 9x plus 5y equals 16. Draw my line. My x's disappear. Right here, I get negative 21 plus 5, which is negative 16y equals, add these together, equals 64. Divide by negative 16. Y equals negative 4. So my solution, remember it's x then y. I know my y is negative 4. Now we need to find the x. Choose one of the two equations. I'll go ahead and choose this bottom one. So I have negative 9x plus 5y equals 16. Y is negative 4. So I'm going to put this up here and put it in for y. I get negative 9x plus 5 times negative 4 equals 16. Negative 9x minus 20, because 5 times negative 4 is negative 20, equals 16. Add, not 30, 20 to each side. I get negative 9x equals 36. Divide by negative 9. X equals negative 4. There's my solution to number 20. Number 21. Is there any letter that automatically cancels out? No. When I'm looking at it, is there a whole number that I can take times 3 to get to 5? No. What about 2 to get to 7? Nope. Okay, in this case, none of these work out to multiply just one of them by. So I need to change both of the equations. Let's first just look at the 5 right here. The easiest thing to do is take, you know that 5 times 3 is 15. So let's change these x's to 15. So I'm going to take the top equation by 3, the bottom equation by 5. Now that they're still both positive, so one of them has to become negative. So I'm going to choose the top one to be negative. You could do the bottom one. It doesn't matter. So now, remember, you have to multiply by everything here. So I have negative 15x minus 6y equals positive 3. The bottom one, multiply each one of the things. I get 15x plus 35y equals 55. Now the x's cancel out, and when you have negative 6 plus 35, that gives you 29y equals 58. Divide by 29. 58 divided by 29 is 2. Y is 2. So right here, my solution, I have my y number to be 2. Take one of the two equations. I'll take this top one. Just out of choosing, I had to choose one of them. Now I'm going to take this 2 and I'm going to substitute it in here for this y, and I get 5x plus 2 times 2 equals, oops, negative 1. 5x plus 4 equals negative 1. Subtract 4 from each side. 5x equals negative 5. Divide by 5. X equals negative 1. There's my answer.